Locally dokily, here goes our lesson on the impacts of mining. By the way, if you don't get the joke on the front, if you've ever heard the saying, canary in a coal mine, miners used to take a canary down, a bird down into the mines with them because if dangerous gases were building up, the canary would die and they would know, hey, we got to get out of here. So a canary in a coal mine is like an early warning sign. All right. So, what is mining? It's getting natural resources out of the earth. The goal is to get ore from the earth, which is a concentrated accumulation of minerals. And a key phrase in this definition is that they're economically valuable materials that can be extracted. You are able to find, for example, gold atoms floating in ocean water, but it would not be feasible to really extract that because it's so dilute. So, some of the examples of the minerals that we're getting are metals, coal, oil shale, gemstones, limestone, chalk, various stones like granite or things like that that we use for building, rock salt, potash, gravel, and clay. Um, One thing to keep in mind is that, however much iron we have on this planet, that's it. We're not getting any more. However much copper we have on the planet, that's it. There's a finite or definitely like quantifiable amount of mineral resources on the planet. More than that, we've actually got, in the center of the earth, there's iron core, but we can't mine that for iron because it's too deep. We can't get to it. And so this kind of availability, you have to have stuff that's fairly close to the surface. I believe while I was looking for this information for this lesson, the deepest mine is like 2 to 3 kilometers deep. And then below that, there might be more deposits of coal or oil or diamonds, but we're not really able to get to them. Um, so there's a finite amount of resources on the planet, and then there's also a finite amount that we can easily access. So mining is important because it provides low cost energy. This is mostly for when mining coal and material to make different products. So what do we mine? So this is a lot of the metals that we mined in, I believe this is for the year 2020. So iron ore makes up a large chunk of the metals that we mine. We use it for steel, for tools, for all sorts of purposes. Then aluminum is also mined. You make cans out of it, as well as electronic devices and aircraft parts. Copper is also mined, but it is used primarily in wiring. We do mine manganese, which is used to make steel, and is also an important ingredient in lithium ion batteries. These are like rechargeable batteries, so the kind that you'd find, say, in an electric car. Chromium is also used to help produce stainless steel. We have other minerals and metals that we mine, so lead, nickel, zinc, titanium, beryllium, some mercury, bismuth, uranium, which is used to produce energy, strontium, magnesium. And then there are some much rarer elements that we use for technology. So, lithium, for example, is a very important component of lithium ion batteries, hence the name. Indium is important for making touch screens, TVs, and solar panels. Niobium is made for engines, is used for engines. So we mine some tin, molybdenum, various rare earth elements, cobalt, lithium, tungsten. So all sorts of things that we're mining. Those are the metals that we're mining. Then some of the commonly mined minerals or ores, bauxite is the most common aluminum ore. This is what it looks like up here. And then this is what the refined aluminum looks like. Iron ore, one common type is hematite. You may actually see people wearing like jewelry from hematite. I think I have a bracelet made of hematite beads. It's a rock that's actually magnetic because it contains a high amount of iron. Phosphate is usually purified from either bat guano, which is, yes, bat poop, or the mineral apatite, which looks like this. And then zinc, like from this zinc ore right here, is used to galvanize or help rust-proof metals. So those are just some of the minerals that we mine. Now, what you need to keep in mind is there are reserves of these minerals. That's how much we have left. People have been mining for millennia, gathering metals, etc., gathering materials. And so some of the supply that we have has already been either used in the case of energy resources like oil, coal, and gas. Um, then some of it is reusable. For example, you can recycle aluminum very easily. And then, so there are limited amounts of all of these materials. So we have enough oil to last until a little after 2050 at current rates of usage. Coal, if we continue to use it as we do now, we could last till about mid through the 2050s, although if we decreased our consumption, we might be able to have coal sources until like 2136. Um, Uranium, if we use it as we do now, we've got enough to last until like 2040-ish. Similarly, for example, indium, we have enough to last until maybe 2030. Gold, we're actually like running lower on gold. Funny thing, uh, it's kind of a bit of a stereotype that Indians are very, very into gold, which my family is. My mom used to look for good prices on gold and she used to buy gold. And then gold production has declined. There are less amounts of it available. And so it got too expensive. And so now no more gold jewelry, which I'm perfectly fine with. I like the fake stuff better because you don't have to worry if you lose it. All right, so let's see. This diagram is showing where you have a lot of the remaining reserves of these materials. So here in the United States, we have um, oil, some. We got a bunch of coal. We have some gas, natural gas. We have uranium. Here's antimony, indium, etc. Some of the other resources, for example, silver, gold, and copper, comes from South and Central America. That's where we have plenty of reserves. Things like indium and rare earth metals, there are lots of those deposits in Southeast Asia. So those are the areas where we'll likely be producing those in the future. Notice Europe and the Middle East, except for oil and gas in the Middle East, tend to have a little less of some of these resources. In Europe, especially, it might be because a lot of those mines that are easily accessible have already been mined. So now let's talk about how we mine before we can talk about what the effects are. So we're going to talk about two major types of mining. The first is surface mining, where you remove ground, dirt, rock, etc., and you're trying to reach a relatively shallow layer of ore. You use bulldozers, other earth moving equipment to move aside the topsoil, vegetation, and the soil and rock that are on top of your ore that you're trying to reach. And that soil and rock is a waste product, kind of. It's called overburden. Ideally, you should keep it so that way, once you're done mining, you can reclaim and restore the area and you put the overburden back. Unfortunately, it produces large amounts of waste material, especially if you don't take care to secure your overburden in soil. However, it is cheaper and safer than the other type of mining, subsurface mining. So we're going to talk about each of these types of mining individually. Strip mining is useful mostly when you have like a horizontal layer of a mineral or material that you're trying to reach that's pretty parallel to the surface. So here you see a couple of diagrams. This is the level of the land before you come in and start, digging. Here is a deposit of, for example, coal. Notice it's mostly horizontal, fairly close to the surface. And so you dig underground until you reach your mineral that you desire, and then you go ahead and you grab it. If you have more deposits, you can get more. Here's some overburden. And so you're basically, I visualize it as you like kind of peeling away strips of land almost. Very commonly, this is used to mine like coal or phosphate, and some of the environmental impacts of this, it removes the vegetation from the area and disturbs the local ecosystem, destroys habitats, etc. If you're not careful with your topsoil when you remove it, it can lead to soil erosion, which will lead to reduced fertility once you put the soil back. All mining, when it rains, water's going to go into a mine. Um, and it can pick up chemicals from the rock. And those chemicals can be leached out and then end up going into groundwater supplies. And then, of course, all of these forms of surface mining are going to destroy wildlife habitats. And for each of these, I have a diagram that kind of shows you how it works, and then a picture of that actually happening. So the picture right here is showing you an actual strip mine. Then open pit mining is where you basically are digging an open air pit. The reason why you would go for open air rather than strip mining is, let's say this is your ground surface and you've got more than a horizontal layer. You've got like a deeper pit or a deeper chunk of material that you're trying to mine. So you basically dig these rings of earth out of the ground. Um, and this is also a very common practice when the ground is not the type that you can easily tunnel in. Because if you're trying to do subsurface mining, you need a rock that will stay supported even when you start digging holes in it. Otherwise, you can have mines collapse. So, open pit mining is often used to mine coal, copper, and diamonds. It's got the usual impacts of any surface mining, which is affecting vegetation, soil, can affect the bedrock, especially if you dig very deeply, and then, of course, water levels. And a lot of times with these types of mines, you actually have to pump water out because when it rains, water gathers in the bottom. And then once you're done, it just starts to fill up. So sometimes, as part of reclamation, they'll actually make artificial lakes out of these. And all mining, depending on what type of chemicals, the chemical composition of the rocks, what you're trying to mine, can produce harmful pollutants. Mountaintop removal is pretty destructive. You basically use explosives to blow up large chunks of mountains. So, for example, in this diagram, this is the former mountain contour, so that's how high it was. This is where a coal seam is. So, you basically explode the top of the mountain. So that way you have access to the coal seam. This is extremely environmentally destructive. However, mining companies prefer it because it's less expensive and you can do this with less employees. So this started happening in the 1970s in the Appalachian Mountain region. It's more common here in the United States. There's a lot of environmental impacts. You're destroying habitat, definitely when you blow it up. Another thing is the overburden, which can be contaminated by toxic byproducts, is often dumped into nearby valleys. So you're not only destroying the habitat of the mountain that got exploded, you're also destroying the habitat of those valleys because you filled them in. And here's another thing. Those valleys, a lot of times, some of them are cut by rivers, so you're disrupting the flow of water. And that can also lead to watershed contamination. So here on the bottom image, that's a satellite image. Here is the area after mountaintop removal. Here it is before mountaintop removal, so that you can kind of see some of the impacts. So subsurface mining is underground mining. You dig tunnels, you dig shafts in order to reach buried ore deposits. They're usually deeper. The rock needs to be stable enough that you can actually dig without it collapsing behind you. And then it's really important to have good ventilation because when you're mining, not only do you create dust when you're like breaking the rock, but you can also have your diesel equipment release carbon monoxide and particles like soot. And then there are some natural gases that are released from the ground, like radon gas, which we'll talk about more in a future unit. And then another thing is some of these mines can be either extremely hot or extremely cold, and so the ventilation helps to regulate the temperature as well. Now, the advantages of subsurface mining is that it causes less surface destruction, and you're not creating as much waste rock because, for example, you're not removing all of this, you're just digging into it. However, it has much lower safety I mean, much higher risk of safety accidents for workers. So here, by the way, is a coal mine, and this machine is pretty much scraping coal out of a seam of coal. And then, so some of the stuff is done by machines, but there are still miners down there. So, what are the ecological and economic impacts of mining? Well, one big thing is mining waste. So, some of the types of mining waste you have overburden, which we've already talked about. But for every ton of ore that gets mined, it produces about 5 tons of overburden. However, overburden doesn't necessarily have to stay a mining waste if you use it to help restore either other mined areas or the area where you took it from. So a couple of types of waste. There's gangue, which is waste rock that may have some ore mixed in with it. So you may be able to do some processing to remove some of the ore. And then mine tailings, which are finely ground rocks and other waste that's produced when you're processing and trying to extract the mineral from the ore. Sometimes chemicals are used to take out these minerals, and so those chemicals can end up contaminating the mine tailings, and then this stuff has to be disposed of properly. So a lot of times they'll have tailing ponds to capture and store waste. So here's a diagram of a tailing pond. Here's water, here's tailings that end up deposited, and there's supposed to be a dam or some sort of barrier to prevent those tailings from escaping. However, if they're not constructed properly, there have been several examples that I don't have up here of these dams breaking and tailings and mining waste and all of that um, escaping almost like a landslide and destroying and contaminating large areas. Then, when you're extracting or smelting, which is the processing you do to purify ore, that can produce slag, which is the waste product. So, all of these things have to be disposed of properly. Like I said, whenever there's a mine, you're digging a hole in the ground. Anytime it rains, you're going to have water going in. Water is very good at picking up things in solution because it is the universal solvent. Water is responsible for leaching or dissolving out chemicals from the rock. Unfortunately, if you have a lot of sulfides or other chemicals that easily form acids, that can make the water as it drains out of a mine very acidic. And so that's called acid mine drainage. And if that ends up going into the local water supply, it can be have a very negative impact. It can kill local wildlife. It can contaminate drinking supplies, etc. Then there's sludge, which is wastewater that has some solids and processing chemicals mixed in. Sometimes, if it's harmful enough or radioactive enough, it could be classified as hazardous waste. So this top diagram, this is acid mine drainage. I'll just call it AMD. And this right here is acid sludge. So this is an aerial photograph of acid sludge released from some coal mines in Germany, which, yeah, looks like radioactive orange soda. So let's talk about what coal mining can do because a lot of the mining we do throughout the world is to get sources of coal because coal as a fossil fuel gives us relatively cheap, easy energy. Unfortunately, it can destroy habitats. You can have contamination of groundwater, and it can also release dust particles into the air and methane. Another problem is a lot of the coal that supposedly thousands of years ago, sometimes you'd find coal deposits just exposed to the air. You might find coal on the ground that you could pick up. But as people discovered, hey, when I burn this stuff, it lasts for a while and produces a lot of heat, they started burning all the easily accessible coal. When you're mining, you're obviously going to dig up what's easily accessible first. Then, when you start running out of that, you have to reach for more and more difficult sources of coal. So, the surface mine accessible coal is being depleted, and now to get coal, we have to go to the more expensive and less safe subsurface mining. So, we may not run out of coal as much in your lifetime, but coal will become very expensive because the cost of getting it out of the ground is going to be higher because we have to use more expensive means. So, in this graph, what I wanted to point out is the millions of tons that are mined. And notice that you have the blue, this is surface mining, and this is subsurface. So notice that the amount of the tons that are mined from subsurface mining has decreased, but not a lot. But the amount of coal that's being mined through surface mining has almost decreased in half, close to half. So it went from about 813 to about 501 million tons. All right, that's mining, and more lessons coming up.